Hi everyone, I'm Cheryl. In this problem, we're asked to find the angle of inclination between the xy plane and the tangent plane to my surface 3x squared plus 2y squared minus e equals 15 at the point 2, 2, 5. All right, well, what do I mean by that angle of inclination? Well, if you can imagine, I have a plane that's sitting on the xy plane, and then I'm going to look at a tangent plane to my surface. So the angle of inclination then is going to be this angle between those two planes. Okay, so to calculate that angle, I know that the cosine of my angle of inclination is going to be equal to the absolute value of the dot product of a normal vector times the dot product of my normal vector and k divided by the norm of my normal vector and the norm of my vector k. Now remember, my vector k I know is a unit vector, so I can simplify this formula to the absolute value of the dot product of my vector n and k divided by the norm of vector n. Okay, now this vector n needs to be normal to my surface. So what I can use is the gradient of f. And I'm interested in what's happening at the point 2, 2, 5 for this problem. So I'll take that and I'll take the dot product of that with my vector k. Find the absolute value and then divide by the norm of my gradient. All right, so what I need to do then is take a moment to figure out what the gradient of f is. Well, notice that I have my surface expressed as an equation. So I'm going to take that equation, 3x squared plus 2y squared minus z. I'm going to subtract 15 from both sides and say that it equals 0. And then I'm going to create my function f of x, y, and z to be 3x squared plus 2y squared minus z minus 15. Now to get the gradient of f, I'm going to need to take the partial of this function with respect to x. So that's going to be a 6x, and that'll be times my vector I. For the next piece, I'll take the partial with respect to y. That will be 4y, and that's times vector j. And then finally, I need to take the partial with respect to z, which is just going to be minus 1, times my vector k. And in particular, I'm interested in this gradient at the point 2, 2, 5. So that's going to become 12i plus 8j minus k. All right, so now that I have my gradient, I can go back to my formula, and I know that the cosine of theta now is going to be the absolute value of the dot product of 12i plus 8j minus k and my k vector, which if I want to, I can write that as 0i plus 0j plus k. And then I'll divide that by the norm of that gradient. So I've got the square root of 12 squared plus 8 squared plus minus 1 squared. Okay. Taking the dot product in the numerator, I'm going to have the absolute value of 12 times 0, which is 0, plus 8 times 0, which is 0, and a minus 1 times 1, so that's going to be minus 1. And in the denominator, I'll have the square root of 144 plus 64 plus 1. Okay. Now, this is going to be the absolute value of negative 1, which is just 1. And when I add all of these numbers together, I get the square root of 209. Now remember, that means that the cosine of theta is 1 over square root of 209. So what do I have? I have that the cosine of theta equals 1 over the square root of 209. I want to figure out what theta is going to be. And I know theta is going to be an acute angle, so something between 0 and pi over 2. So I'm going to go ahead and use my calculator to help me with this. So I'll take the inverse cosine of 1 divided by the square root of 209. And I come up with approximately 1.5. And now remember, this is going to be measured in radians. If you prefer, you can convert this to degrees, and theta is approximately 86 degrees. I hope that was helpful. Thanks.